So in this screencast, we're going to talk about how to use Matlab to write a while loop. So in Matlab, you should write a while loop when, first, you don't know how many times you're going to go through the loop. How many times or iterations you need. But what you do know is the condition you need in order to stop. And that's why it's called a while loop, right? It's going to run the loop while or as long as a particular condition is true. So to execute that while loop, you need this following structure. First of all, you type the word while, space, and then that in MATLAB, while is a special word, and when you type it, it'll turn blue. And you hit a space, and then you type in a condition here. And after that condition, you type in a set of code that you want it to execute over and over and over again until that condition becomes true. Or sorry, becomes false. So for example, the condition might be initially, or it might be something like, say the absolute value of some variable, say delta t, is greater than 10 to the minus 6. So as long as this condition is met, the absolute value of delta t is greater than this 10 to the minus 6, then the while loop will still keep operating. Now this condition, so before the loop starts, or before each iteration of the loop, MATLAB checks the condition. Condition. So if the condition is true, then the loop runs. Well, it runs once, right? The iteration runs. And then if false, then the loop doesn't run anymore. The loop stops. Okay, so initially, of course, you usually write it so that the condition is true in the beginning. So you go through the loop a certain number of times, and then as soon as the condition is not met anymore, then MATLAB stops running through the loop and then continues on with the code that happens after the word end. Now there's one important point here, is that as you're going through the loop, whatever is happening to the condition, something about it has to change, right? So for example, if I go back up to what I had up here, in the example condition here, this delta t variable, its absolute value is greater than 10 to the minus 6. As long as that's true, then the while loop will keep executing. That means that somewhere in here in this code, inside the while loop, I have to do something to delta t. And hopefully, eventually, delta t will become less than 10 to the minus 6, the absolute value of delta t. And at that point, then the while loop will stop executing. Now, if that doesn't happen, if either I didn't program the condition correctly, and it never changes no matter what is going on in here, or even if I did program this condition correctly, but for whatever reason, my delta t just never happens to go less than 10 to the minus 6, then what I'll be stuck in is something known as an infinite loop. An infinite loop. And when that happens, then you want to hit Control-C to abort your code. At any rate, this following example illustrates how to use a while loop. So what we want to do here is, using this while loop, we want to write a script that solves the equation x equals cosine of x. And if you're familiar with this, this is an example of successive substitution. Okay, so first of all, for this equation, what we want to do is a guess and check method. This particular kind of guess and check method, or the successive substitution method, will actually converge to a correct answer. That's not always true. But for this particular case, it's true, so we're pretty safe in writing this while loop. And so we want to start with initial guess, say x equals 1, and we'll substitute that into cosine x and see what we get. And we'll do this over and over and over again until x is, quote, sufficiently close to the cosine of x. So when we type that into our MATLAB script, this is what it'll look like. First, we'll take that initial guess, x equals 1, and then we'll write our while loop. I'll get back to this part in a second. We'll write our while loop. Inside the while loop, and I'll get to the condition again in a second as well. Inside our while loop, I say x equals cosine of x, and then I'll just keep going on that over and over and over again, and eventually, hopefully, our condition will no longer be met, and we'll be able to exit outside the while loop. So what is our condition? Our condition was that the difference between x and cosine of x, that absolute value of that difference had to be greater than 10 to the minus 6. So it's just like the condition I was writing as an example above. Now there's another part of this condition that I'm writing here, and that would be both of these two have to hold true. So both x and cosine of x have to be far away from each other, and this variable n steps has to be less than 100. And so that's the second part of the while loop that I've written here. So I have my first initial guess, x equals 1, and I initialize the while loop saying I have taken 0 steps now. And so it enters into the while loop and it checks this. Well, x, the difference between x and the cosine of x, where x equals 1, is greater than 10 to the minus 6. So that's true, so it's going to go. So that's one part of the condition that's met. And n steps is 0, so that's less than 100. So both of those are true. So when they're both true, then the and together will be true. So it enters into the while loop. So the first thing it does is it says x equals cosine x. What that means is I'll take my initial value of x, 1, calculate the cosine of x, and then store that new value into this variable x again. Then after doing that, I increase the number of steps that I've taken by 1. What's going to happen is this while loop will run over and over and over again, and eventually, hopefully, in this case it will be true, x will converge onto the value of cosine of x, so that this condition will no longer be met. Now if that didn't ever happen, then eventually after 100 steps, then this condition will no longer be met, and in both cases we'll break out of the while loop. So this condition, this extra part of the condition here is just sort of like a fail-safe to make sure that we're not going to get stuck in an infinite loop. So let's take a look at that script in action in Matlab. So in this script, the first thing I'm going to do is type in my initial guess. Then I'm going to type n steps equals to 0. So that's sort of initializing my while loop. And I say while. And after I type the word while, you notice that this word turns blue. And what that means is it's a special word in Matlab. So I can't use this as like a normal variable name. So while and a space. And after I say the space, Matlab gets mad at me. It says, hey, look, you know what, you forgot something here. Oh, what I forgot was my condition. So my condition was the absolute value of the difference between x and cosine of x. I want that absolute value to be greater than 10 to the minus 6. So that's one part of my condition. And now that I've written the condition, and Matlab doesn't know I have more to write, it also is angry at me, but now it's angry for a different reason. It's saying, hey, you forgot your end. So just to get this red underline out of the way, I'm going to hit enter a couple of times and then hit end. Okay, so now it's happy. Now it thinks that I have a valid while loop. Of course, it doesn't know that I want to do a little bit more with it. So the second part of the condition is that I want n steps, my variable n steps, to be less than 100. And again, this is the variable this is the part of the condition that's going to tell me if I am stuck in what looks like it's going to be an infinite loop, I'm going to break out of it after 100 steps. Then I'll type in the business part of the code, x equals cosine of x, and n steps equals n steps plus 1. And then I can go ahead and run the code. Now I've saved this file as example.m. So if I switch over to Matlab command, and now I type in example, I don't have to have the .m. And I'm in for loops, and I mean to be in while loops. So I just very quickly changed the working folder that I have here. So I type in example and run it. And what you didn't see is that Matlab went through the iterations, starting with the initial guess of x equals 1, and eventually converging onto a new value of x, or 0.7391. And the cosine of that, 0.7391. And the difference between x and the cosine of x, the absolute value of that being less than 10 to the minus 6. In addition to that, how many steps did I take? 33. And so it didn't reach 100 steps, and also it did converge, and so this is the part of the condition that broke me out of the while loop. And just to reiterate in this example, we didn't know how many times we would go through the loop until we converged. Now it happened to be that we went through 33 times. That's why n steps was equal to 33 in the end. And that's why we used the while loop instead of the for loop. Now, again, like I said, we didn't know if we would ever converge. Maybe we would be stuck in this infinite loop, and so that's why we had this extra condition. And so this is good practice to include this failsafe so that you don't get stuck in the infinite loop. Now, this use of the while loop is really common practice when you're trying to solve nonlinear equations, such as with Newton's method. Of course, in this particular case, we used the more simple successive substitution method, but in examples where you're going to use Newton's method to solve nonlinear equations, while loops are typically the way to go.